right, colored pens up, and let's see how we're doing with writing equations. So, one question, I'm looking for one equation. There's a few different ways to write it, but it's all the same thing. So let's see, we got Anissa, Brian, Sebastian, Maria, and then Kayla. Go. Okay.
Y equals x minus 4.
Okay.
Y equals x minus 4.
We got 3 different answers so far, Maria.
Y equals 1, x minus 1, and
So that's what Anissa
Yeah.
said. Kayla?
Y equals x minus 2.5.
Okay, so I've got 4 different answers. 2 people agree. Sharik?
I have y equals 5 halves x minus 2 and 4.
Okay, so we have 5 different answers, but 2 people agree on one of them. Anyone who agree with any of those answers? Zabari, Alicia, and then Catalina.
Y equals x minus 1.
So that was the one that's a couple people agreed.
Y equals x minus 1.5.
4 people agree on it.
I agree on y equals 2x minus 2.
Okay, so 2 people agree on that. The equation I was looking for was y equals x minus 3 halves, which is the same thing as y equals x minus 1.5. So let's go back and talk about what it is we need to be successful. What are the pieces of information we need to actually provide what I'm asking for? Brandon? Slope and a point. Okay, good. So we have 2 points in this case. But there is this thing that I asked you to set up. Shelby? Mm-hmm. Yeah, we find the slope and the y-intercept, and then we can write out our equation. That's the key that I've taught you to set up for success. And so we usually start at the top and find the slope. What threw some of you off was that there was fractions within the ordered pairs. And there was a couple of people who asked me, what do I do with this? And my response to them was, unfortunately in this case, I'm going to ask you to try and figure it out. Because I'm not just going to tell you what to do when you can very simply use some logic and some thought and figure out what to do. So let's explore what you should have done, or I'm sorry, not what you should have done, but some of the possibilities. First of all, we need the slope, and so we know we need x1, y1, x2, y2. So here's where people got thrown off. So y2 minus y1 over x2 minus x1. So give me a thumbs up if you got the correct answer to the question, so I can start with those people. Okay, so those people who have the thumbs up, you can put your thumb down now. Those people who have the thumbs up figured out a way to be successful looking at this mess right here. So Hezekiah, what did you do to figure out this mess?
I didn't do that. I didn't.
Good. So what did yours look like?
And I got.
Like, rewrite this using your idea.
I got 1 and 1 half minus 3 over 3 minus half.
Good. So that made more sense to you, and then you were able to be successful with that. Good. And so watch what happens when you do it his way. What do you get on top?
2.5.
2.5. What do you get on the bottom?
2.5.
2.5. Does it look that hard now? What happens when you have the same thing on the top and the bottom of a fraction? Equals 1. Okay? And you also had your thumb up. What did you do?
I was in that step, I did just to make sure I did it by 2 and that's So
Okay, but back up for a second for me. How did you do this? Did you do what Hezekiah did?
no, I did it the original way.
Oh, you did it the original way. Okay, good for you.
They keep change.
Good, so you knew that this was really 3/2 plus 1. And then did you write 2.5? Or did you write 5/2? Okay, good. Great for you. Excellent. Okay, and then you multiplied this by 2 and this by 2 because you were a little confused by this, and then you got 5/5, and then you were able to see that it was really a 1. Great job. Brandon?
I actually put the 2 into decimal and change it out.
Good. That was a great instinct. So what does yours look like? You tell me what you wrote for this.
1.5 plus
3 minus 0.5. And guess what you get? You get 2.5 over 2.5, which still equals 1. So there is absolutely no way that I was going to let you rely on me to tell you to convert these numbers to a different form to then do something with them. That's logic and instinct and number sense. And that is all stuff that you are already supposed to be experienced with and have an idea of what to do. Okay? So, you had a number of different options and there were probably more. Any other comments, questions on how to do this? Alicia and then Eric?
Yeah, I got the right answer, but when I was writing it, like, instead of putting m equals 3/2 minus -1, I just put 3/2 plus 1.
Because your instinct took over and you just knew that minus and negative meant plus. Excellent, outstanding.
I ended up writing the points to solve.
Good. So Eric just demonstrated his deeper understanding of everything we've learned from way back over there. Because he recognizes that, yes, I'm asking for an equation, but the equation represents a line. The line has the points on them. So he has just proven to his teacher and to the rest of his peers that he has a very deep understanding of what's going on. Okay? So you graphed the points, and then you just looked for what? You just looked on the graph? What do we call it when we, I'm just going to sketch it, what do we look for? What's it called? What is it called when we do,
Slow.
right? But yeah, there's other terms that we use that should spark some memories for others. Alyssa? Rise over run. So that's what you did, is you graphed it and looked for the rise over the run and got the slope, right? Outstanding. Great job. And this is not the graph. I just sketched that really quick. Very good. Any other comments or questions? This is outstanding work. Questions? Other questions or comments? Good. We're doing extremely well so far. Put the warm up. The past month and a half, we have been exploring in a whole bunch of different ways linear equations. Starting at the end of chapter 3, when we learned the concept of function form, we've been using linear equations, we've been writing linear equations, we've been graphing linear equations, but for the most part, all of the scenarios we explored all came down to the linear equations being written the same way. They were always written in function form, which we then learned was called slope-intercept form. So the end result of the last lesson we did was we learned how to take a bunch of different scenarios and write equations from those scenarios, but the equation was always written the same way, slope-intercept form. Today you're going to learn that the end result doesn't always have to be the same way. It doesn't always have to be slope-intercept form. There's another form of a linear equation. In fact, there's two more. You're going to learn the second one today. It's called point-slope form. As if Algebra 1 Honors wasn't difficult enough, they made the two forms sound almost the same. Point-slope form, slope-intercept form. Wow, they sound the same. They got a lot of similarities that you're going to see in a moment. So it's hard. But part of your job is to remember which one is which and what they look like. Just like if I was looking at Alicia, but I kept saying, Jada, would you please loan me your calculator? She looks at me like I'm crazy.
Please.
But I said, Jada, can I borrow your calculator?
God.
She doesn't know what I'm talking about. Why? Because I'm calling her by the wrong name. So she thinks I'm a crazy person. Just like I think you're a crazy person when you say slope-intercept form, but then you write something else. So you have to know the difference, and you have to know what they look like. Okay? So some of you are going to get confused today, because now all of a sudden I'm throwing something new into the mix. But here's the trick. It's not new. It's the same thing. Just looks different. And the analogy I've used in the past, I'm going to use again today. We've talked about money. And I've asked you before, several times, to tell me a way to make $1. And we got a whole bunch, we got infinite possibilities. 4 quarters, 10 dimes, 20 nickels, a dollar bill, 2 half dollars. There's a zillion different ways to make $1, but they all have the same value. And so I'm teaching you a new form of a linear equation, but it still has the same value. It's still going to draw a line. It's still a linear equation. So here is point-slope form. We have a point, x1, y1. This is the point-slope form of the equation that passes through that point. I have 3 pieces in red. The pieces in red are the pieces that we provide. The pieces in black are the pieces that are always going to stay the same. So y minus is always going to be there. We provide this. The equal sign is always going to be there. We provide this. Open parentheses, x minus, always there. We provide this. Close parentheses is always there. So again, I'm just trying to emphasize that even though it seems new and it looks different, it's still the same thing. 4 quarters is $1, 20 nickels is $1, it's the same thing. A different way of looking at it. So, as always, I break down what we have to do into a sequence of steps so that we have something comfortable that we can rely on. Excuse me. Thank you. Appreciate it. Okay, I apologize. So, writing an equation in point-slope form. Some of you are going to instinctively know what to do. Some of you can look at the form and say, oh, I know what I need, I just need to fill it in. But since we have a variety of skill levels in the room, I'm going to provide you with a sequence of steps that will lead you to success. Step 1, find the slope. Now that looks pretty familiar. That's been our step 1 for a long time now. We always need the slope when writing one of these equations. Step 2, choose one point and then plug in all the information into the form. So it's a 2-step process. Here's one aspect that you will initially find confusing, but as I demonstrate and as we go through today's lesson, you will start to sort it out. And that is this. A linear equation can have many different versions in point-slope form. You're not going to understand right now why, but in a little while you will understand why. But when we write it in slope-intercept form, it will always be the same. In other words, there's only one slope-intercept form. There are many point-slope forms. Does anyone have any questions so far? I know you haven't seen what we're going to do yet, but does anyone have any questions about the wording or anything at all? Go ahead.
The things that we provide, right? I don't know if you're gonna explain it tomorrow. Like x1, is x1 like is x gonna be from x1?
That's actually a really good question. I am going to explain. X1 and Y1 really just mean an X and a Y from an ordered pair. And you're going to see in a little while that it actually doesn't matter which ordered pair you choose. Okay? Catalina?
You know how for step 2 it says choose one point
Mhm.
and plug in the coordinates? Isn't one point from the coordinates? Like, don't you get like if you choose one point, don't you get that from the coordinates?
I guess I'm using the word point and the word coordinate to mean the same thing. The coordinates, a point is made up of two coordinates, an X coordinate and a Y coordinate. That's what a point is, okay? Okay, if it's still confusing in a little while, just let me know. All right, so we're going to jump right in and we're going to explore how to write equations. So, example 1. As always, you need to read these instructions carefully because you're going to see the same wording in the workbook and the textbook, but you don't have to copy them down. So, we're still being asked to do the same thing we were asked to do last time, and we're still being asked to do the same thing we were asked to do 2 lessons ago. Write an equation. This time, we're going to write our equations in point-slope form. Now, I'm going to write something down that I don't want you to write. I'm going to write it in orange. Whatever I write in orange, you don't have to copy. So, when you learned how to write an equation in slope-intercept form, we set up a key for ourselves, and we did this during the warm-up. And this is what it looked like. And you still need to know how to do that if I ask you to write something in slope-intercept form. But now we need a key that works for point-slope form. Point-slope form does not have this. It does not have the y-intercept. It has something different. It has a point. So instead of using this key, we're going to write a different key. So you still need to know that when it's slope-intercept form, that's the key you use. Now we're going to use a slightly different one. We still need the slope. This time we need a point. And then we need the form. Y minus something equals slope times the quantity x minus something else. And we're going to work top down. We find the slope, find a point, plug it in, and we're done. So we need the slope, and we need to get it from this information. What can we do? There's 3 confident hands. 6 confident hands. 7 confident hands. 8. Okay, that's good. Ania? I'm sorry? Good. Excellent. What are we going to do after that, Catalina?
You're going to use a slope formula to calculate the equation.
That's it. And so we're advanced enough, and we've been doing this so long now, that when I ask you how do we find m, you can just say slope formula, look at the graph, rise over run. You can be pretty general because most of us already understand what to do. And we do what Ania said, which is we're going to label x1, y1, x2, y2. And now we're going to calculate slope. M equals negative 10 minus 6 over 4 minus negative 12. Do some mental math quickly, and what do we get? Dianar? You get negative 1. The top becomes negative 16, the bottom becomes positive 16, and of course we get negative 1. So we already have one piece of information that we need for the form. We've got the negative 1. That goes right there. But now we need the other piece of information. We need the point. So where are we going to get that from? Where are we going to get that? Tristan? Yeah, they're right there. We got 2 choices. And here's what I meant by the fact that there's more than one possibility. it actually doesn't matter which point you choose. Both are correct, but you have to pick one. So we'll pick the first one. So the point is negative 12 comma 6. So now we have to plug in things correctly. This location is the y value, so we put the 6 there. This location is the x value, but that's a negative number, so now I need to be careful that this is going to be negative 12, like that. Once we have this, now we need to make it look the way it's supposed to look. For example, we don't write negative 1 when it's in front of something, and we do not write minus a negative. So we need to just fix those two things, and then we will have our equation. So someone give me the left-hand side of the equation. What's the left-hand side going to be? Kamoy? Y minus 6. Y minus 6. Good. What's the right-hand side going to be? The left-hand side didn't really need to be modified. What's the right-hand side going to be? What do we write negative 1? What do we write instead? Kezekiah? You're spending way too much thinking about it. It's something that should be instant. And I'm not trying to make you feel bad, but you're overthinking it. Alyssa?
Minus x or negative x.
Well, but we want the form to stay like this. So we want the parentheses to be there. So we're not, I think in your mind you distributed it. Yeah, we're not distributing it. So we don't write the negative 1, we just write a negative sign. And then we've got x, but what's going to happen with that other thing that I highlighted? Sharik?
It's going to turn into a plus sign.
Yeah. So even though the form says that it's supposed to be minus, you have to change it so that it looks correct. We don't write minus a negative. We write plus. And so this is point slope form of the equation of that line. Does anyone have any questions on how we put this together? Okay? No questions? Okay, part B. Now that we've seen it, now that we have an idea of what to do, we can work a little bit faster. So we still need the same information. Point slope form, we need the slope, we need a point, and then we can write the model. Y minus some number equals the slope times the quantity x minus some number. So what do we need to do first? What do we need to do first? Kisara, what do you think the first thing we should do? Beautiful. How are we going to do that? Beautifully said. Outstanding. Slope formula. x1, y1, x2, y2. Some quick mental math. What do we get for the slope? Anil? I'm sorry, I thought you had your hand raised. Okay, I'll come back to you for the next one. Shelby? Negative. Okay, but that's not simplest form, so you're right, that is what it simplifies to, but it has to be simplest form always. Anissa? Negative 2/3. Very good. So the slope is negative 2/3, and so we already know that this is going to be part of the form. So now we need one of the points. Which point should we use? Anil? Sure, we'll use the first one. So we're going to use 24, 7. So now you need to plug the information in the right place. The 7 goes here with the y, and then the 24 goes here with the x. And that is point slope form of an equation. Does anyone have any questions about how we got this? Here and then here, go ahead.
What is the greater y and x in it? The one that you don't, that just stays the same.
It's part of, what do they stand for? They stand for the locations where you're going to put other ordered pairs to test if they're solutions to the equation. So if I want to find out if this is a solution to this, then I plug those coordinates into the x and y, and then if it comes out as a true statement, then I know that that is on this line. And then you can give me another point, and I can test it out. Okay? Good question. Come on.
Now you said you can use like either point or homework, but when you give us the answer in our homework, what if we take the second point and you put that?
I'm going to give you both answers, and we're going to actually do the second one right now. So to make sure that everyone is understanding, and I'm glad you brought that up. So this is only one possibility. We used this point. And I know that the form says x1, y1, but it doesn't really matter. It really means any x and any y from any ordered pair that we already know is on the line. So there is another possibility. So everyone with me, we're going to write the second one. It's going to be y minus some number equals the slope times x minus. So we have the same slope, so that's going to be the same. And now use the second point, 12 comma 15. The 15 goes here, the 12 goes here, and now we have a second equation that represents the same line. Another way for me to say that is this. I have software on my computer, and if we have time later, I'm going to put it on. I have software on my computer where I can type in an equation and it will draw the graph for me, just like a graphing calculator. If I type this into the software, it will draw a line. If I type this into the software, it will draw a line. What should I see? Same line. In fact, I'll only see one because it's really both lines lying on top of each other. And that's the point. They represent the same thing, right? I kept saying about the value, 4 quarters, 20 nickels, same value. They look different, same value. Okay? Hezekiah, and then I got to move on.
Can you practice for both?
Nope. Usually on the home... look, it's possible I would ask you for both, but on the homework, I believe it asks you for one equation. And when I give you the answers to the homework, you will get both possibilities. Okay? Good. Now, you have 2 choices for part C. You can either put your pencil down and focus up here, or if you can't focus, then you keep your pencil in your hand and you copy everything. So your choices are just to focus up here and then you don't have to write anything, or if you can't focus, then you have to copy everything. It's your choice. So here's part C. It's presented differently. So there's really just one thing I wanted to point out with part C. That even though the information is presented differently, it's really no different than part B. It's just presented differently. So if I want to write an equation of this, I already know that Eric knows exactly what to do because he did it during the warm-up. He already makes the connection between the equation and the graph. And I think a lot of other students in here do as well. So we still need the same information. We still need the slope. We need a point. And then we can fill in the y minus, excuse me. But how can I get this information from this situation? Good, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10. Very good. And I love how she said it so nonchalantly, like it's like everybody knows it's just rise over run. So yeah, so I don't have to calculate it. I can just do rise over run, and I will immediately know that the rise is 2, the run is 4. So rise over run, the slope will be 1/2. And then I have a point right here and a point right here, and I just fill it in. So this situation actually has its benefits. If you forget, you can always take the coordinates and use the slope formula like we did here, and you will still get the same slope. Okay? Yes.
And for me, when you're gonna do it with this formula, how do you know which
Anyone know the answer to that? Left to right? What do you think, Brian? Say that again a little louder.
It doesn't matter.
Yeah, it actually doesn't matter. You actually get the same answer no matter which way you do it. Nobody ever discovered that? I never told you.
I knew that.
I never told you, but it actually doesn't matter if you make this one x1, y1, and that x2, y2. Calculate the slope, but then switch it around and make that x1, y1, and that x2, y2. You still get the same slope.
It's just upside down.
Nope, you get the exact same slope.
It's upside down.
Do it right now. Go ahead.
you know how they gave us those 2 points on the graph?
Yep.
Well, I see another one and it's a simplified form. Do you still have to put to
Oh yeah, you can use right there. You're talking about? Yeah. So you could just go boom, boom, and you found the simplest form. Very good. That's outstanding. So you now are proving to me and your class that you have an even deeper understanding of what's going on. And that's fantastic. Okay, so let's see how we're doing so far. Checkpoint number 1. You got one on your own. Let's see how you do. You got 2 minutes. All right? What'd you get? 1, 2, 3 confident people, 4 confident people, 6 confident people. We'll start with Eric, Hezekiah, Kamoy, Brian, Anissa, Alyssa, and Jada. Go.
Y plus 9 equals 9/7. How do we say?
Someone want to help him say the next part? You're missing a part. That's the part he was trying to get help with. Dinar? Yeah, times the quantity of. So go ahead, Eric. Say your answer. Say the whole thing. Go ahead.
Y plus 9 equals 9/7 times the quantity of x plus 6.
Good. Who's next? Go ahead, go.
Y minus 9 equals -9 over 7 plus min. I want to do x minus 7.
Okay, who's next? Come on.
Y minus 9 equals -1 and 2 sevenths times the quantity x plus 3.
Okay,
Y minus 9 equals negative 9 over 7 times the quantity of x plus 20.
okay. Go ahead.
Y minus 9 equals negative 9 over 7 times the quantity of x plus
Okay, so you guys agree. What do you think, Alyssa?
Y plus 9 equals negative 9 over 7 times the quantity of x plus
Okay, so you have something different, Jada?
y minus 9 equals 9 over 7 times the quantity of x.
Okay, so there are two possibilities. Y minus 9 equals negative 9 sevenths times the quantity x plus 20, or y plus 9 equals negative 9 sevenths times the quantity x plus 6. Two different answers, both are equally correct. But a few of you, when you volunteered your answer, did not say negative 9 sevenths, so if you did not write negative 9 sevenths, it's not correct. Has to be negative 9 sevenths. Comments, questions? Come on.
I wrote -1 and 2 sevenths.
Could someone explain why she will actually get that answer marked wrong? Sebastian.
Because when you go to because the slope, when you go to determine the equation slope, you can't. It's really hard.
Okay. Why? Why is it so hard?
Because it's the rise of the one, you can't rise the whole
That's right. So slope, and his explanation was great. Slope must be in improper fraction form, okay? So I know that you know what you're doing. You demonstrated, you know exactly what to do. You went an extra step that you shouldn't do, okay? Any other comments? Ania and then Catalina?
I got everything right except for the slope.
Okay. Okay. I'll come back to you in a moment. Okay. So, also, while you guys were working to answer Kamoy's question and other people, up here on the board from the last example, I did the slope two different ways from these 2 points. This is x1, y1, that's x2, y2, and that's the slope. Then I flipped it around. That's the slope. Yes, it's different along the way, but it comes out when you simplify it to the exact same thing, and that works every time. So you can actually make this x1, y1, x2, y2, or you can flip it around. It will not make a difference. Maria and then Jada.
How'd you get y plus 9 with negative 9?
Because the form, you don't put y minus negative 9. So if you chose that point, if you chose this point, then you have to change this to y plus 9. Okay? It's just one of those details that you have to know in this class. Okay, Jada? Same question? Okay. So we still had a question about slope. So m equals y2 minus y1 over x2 minus x1. Negative 9 minus 9 is negative 18. Keep change. That's 14. They're both divisible by 2. Negative 9 over 7. Okay? So now I'm moving on. So now, example 2. How do we graph something in point slope form? Now, I'm going to write something down, as I've said. I'm going to write it in orange so you don't copy it down. Here is a totally different equation in a different form. What form is that I just wrote in orange? Kayla? That's slope-intercept form. When we graph with the slope-intercept form, how do we start? Hold that thought. Got it? Yes? Thank you. When I start graphing, if I wanted to graph that right now, how do I start? I should see a lot more hands. How do I start? Go ahead, Kayla, you're on a roll. Say that a little bit loud. Right. So this is our starting point. To graph, we need a starting point. So we still need a starting point with this. It's just going to be different than the y-intercept. So we still need the same information to graph. We need, now you can write along with me, we need the slope and we need the point. This time, instead of the point being written as an ordered pair, now we have to pull it out of the equation. So the slope is easy. The slope is what, Zavari? So we know the slope is -3 over 2. But now I need the starting point, and I have to get it from here. What's the starting point? What's the starting point? Tristan?
X is -5 and the y is 4.
Very, very good. This is a little bit tricky, but it is always going to be the opposite of the number that's here, because this is really x minus -5, and this is y minus 4. So this is really a -5, comma 4. Okay, that was outstanding. So this is our starting point, and then we use the slope. So now, I did distribute rulers, or you have your own. So now, we're going to draw our coordinate grid. And now we go to our starting points. Our starting point is -5, comma 4. 5, 1, 2, 3, 4, 5. 1, 2, 3, 4. Put a point, and now I can use the slope. Remember, when it's a negative fraction, it means either the top is negative or the bottom, not both. So I can go down 3, 1, 2, 3, over 2. 1, 2, put a point. Down 3, 1, 2, 3, over 2, put a point. Now use my ruler to draw a line through it. Any comments or questions? James? Well, it is a bit tricky, but the form of the equation is this right here I have on my whiteboard. Y minus y1 and x minus x1. Okay? So what happened was that to write this correctly, we changed this to this. So now we have to go backwards so that we see it that it is a -5. Here's what I usually think of. What number would have to go here to make this a 0? -5. What number would have to go here to make that a 0? And so those are the coordinates. Okay? It does get tricky, and that's where most of my students are going to make mistakes. Okay? Comments or questions? Okay? Now, we're not going to actually do all of part B, so don't worry about setting up a grid, but we need to look at a situation that's unusual. So write down the equation for part B, but we're not going to graph it. You already know how to graph. But this one looks different. So to graph it, I still need the slope, and I need my starting point. The slope is easy. I can see it right there. It's -3. But something's different about this. So what's your interpretation of what you see? Brandon and then Brian? I love the way you changed what you said. That was really good. Yeah, the y coordinate, we can't see it. Brian, what do you see? Okay. So in actuality, both of them are right. We would have to rewrite this in our minds so that it looked like this. Because this is really what's going on right here. Y minus 0 equals negative 3 times the quantity x minus 4. Now you can see the point. The x coordinate is 4, the y coordinate is 0, and now we could graph from that. Comments, questions on how we did that? Comments, questions? Okay, let's see how you do on your own. Checkpoint number 2. Graph this one. You got 2 minutes. I see some people still finishing up. Go ahead and take another 20, 30 seconds to finish up. All right, so here's what your graph should look like. Okay, comments, questions on how this was done? We'll start with Kamoy and then Kezekiah.
I did run over it.
Okay, so yours going the wrong way?
I did not over.
Okay, Kezekiah?
Right? I got the same point at the same place, just that I put the line in the wrong direction.
Okay, so that has to do with slope. And here's the thing. Again, I want to talk about negative 2 means negative 2 over 1. And remember that when you have a negative fraction, the negative sign is either on the top or on the bottom. So that means you could either go down 2 to the right 1, or you could go up 2 to the left 1. Either way, you will get the same thing. Okay? Thanks. Brandon?
Do you want this?
Yeah, it should have.
Oh, you look so nice.
You look so pretty.
So it has. Yes, it should have the arrows in either direction. Thank you. Yes.
Mine was on the other side, like not flipped around, but
Right.
just up there.
Oh, so then your starting point's in the wrong place.
Yeah.
So the starting point is supposed to be negative 1, comma, negative 1. But, and we talked about, this is not a, we talked about how this really means x minus negative 1. And this really means y minus negative 1. And so it's negative 1, comma, negative 1. It's not easy, so I don't blame you. All right, we have a couple of other scenarios. You guys are doing a good job, but we have a couple of other scenarios to explore. So stick with me. So, example 3, you don't have to copy the text of the question. You have to read it, but you do need the table. Okay, so first, this time we're being asked, is this a linear equation? So we're not being told it's a linear equation. We have 2 points, so we can always make a line out of 2 points, but does that mean all of these points will be on the same line? So this is the kind of question that if you can understand and be successful at, demonstrates that you not only know what we're doing today, but you know what's going on for months. So how could we figure out if this really is one line? There's many ways. Start with Sharik, and then Kayla, and then Alyssa.
You can do it like you can do it the regular way and try to like calculate like the slopes, although that would be the long way.
Okay? Calculate slopes, and what would we look for?
We would look for like which one like has which one if like which ones have like the same slope, and if all of them do, then we can tell that it's on the same line.
Okay, what were you going to say, Kayla? Okay, and when we plot the points, what would we look for? Okay, Alyssa?
Wouldn't you be able to tell because they're all multiples of 0.2?
Okay, maybe, but it's not just if there's a pattern in one of them. There has to be an established pattern in both the x's and the y's. So yeah, if you can extract a pattern, that would also be a way to tell. Brian?
You find the slope of 2 points, and then you write the points of form, and then you test each point inside of the form. See?
That's another way to do it. So that's fantastic, and that way hasn't even been brought up. And I'm very impressed that the first person I called on figured out that the slope way was one way to do it. And he was right, it is a long way to do it, but I'm going to show you a way that as a team we can do it pretty quickly. But he's right, and Kayla is right. If we plot all the ordered pairs on a graph, If it moves in a line, then we know it's a linear equation. If the slopes are all the same, then we know it's a linear equation. If we write an equation using two pairs, and then plug in the other pairs and see if they come out true, that will also tell us if there's an equation. If we can find the pattern between the x's and the y's, that will also tell us. In this section, what Florida State would like us to be able to do is use the concept of slope. So we're going to divide the work up. Okay, we've got 1, 2, 3, and I'm going to use myself as another team member. So this first column of students, this is x1, y1, and that's x2, y2. This middle group of students, you are going to do, so you guys make sure, you can go ahead and get started. The middle group, you are going to do, this is x1, y1. You're calculating slope from 2 points.
Oh, you didn't say that.
This is x1, y1, x2, y2 for the first group. This is x1, y1, x2, y2 for this middle column of desks. For Brian and Anissa's column, you are going to do right here. x1, y1, x2, y2, you calculate the slope. And I'm going to do the last one myself right here, so I'm going to use this. So go ahead and you calculate the one that I've assigned to you. I'm going to do my job up here. If you're confused about what to do, you can watch me up here, but you shouldn't be. So you should be done. So let's see. This first column got to start right away. What'd you get for the slope? Shelby and then Stephanie. What'd you get? What'd you get? Okay. What'd you get? 0.402. But that doesn't really mean anything to me. So can we write it in a different way that's got more meaning? Maybe look up at the board and see what I did. Brandon? What is it? Is that in simplest form? 1/5. That's what it comes out to. So theirs came out to 1/5. They used the first 2 points. What about this group here? Maria, what'd you get? 1/5. What'd you get, Dianara? 1/5. What'd we get over here? Kamoy? 1/5. And you can already see that I got 1/5. So when we compare the slopes between them, we can see that they all have the same slope, which means that they are all on the same line. Now, since it does form a line, we are asked to write an equation in point-slope form. Point-slope form is very convenient because once we have the slope, all we have to do is pick a point and write the equation. From this question, how many different equations could we write? How many different equations could we write from this one situation? Jabari? Yeah, there's 5 different points. We can write 5 different equations.
There's 5 points.
There's 5 points, 5 different equations. It doesn't matter, they all represent the same thing. So, y, I'll use the last one because it's both positive, y minus 0.2 equals 1/5 times the quantity x minus 8. And that is an equation of this line written in point-slope form. It could have been any of these points. Does anyone have any questions? Here, here, and here. Yes?
Isn't there more than kind of equation? Like, can't you like combining some like for the
Well, there are actually infinite. We could find even more points on the line and write even more of them. I don't know if that's what you mean. What do you mean by combine them?
Like, you know how the slope-intercept form that would be just for one each? Wait, hold on, I'm confused.
Don't worry about it. Just wait till the next question and then you'll understand. Okay? But 0.1 over 0.5 is not really a valid way of writing a fraction because we don't write decimals within a fraction. So multiply the top and the bottom by some number. There's one number that if you multiply the top and the bottom by, it will become a nice fraction. Okay? There was another question? Hezekiah?
Instead of like you put x over here, you have a 4 over negative 0.6 and 6 over negative 0.2.
Yeah?
But I didn't like, because you put 4 into the x1 and the 32, I didn't do that and I put 4 over 4. I didn't, I just came out the in the slope. Then I was negative 0.2 minus negative 0.6
Yeah.
over 6 minus 4.
Right?
And then I got 0.2 over 2, and I got 5.
0.2 over 2 is not 5. You did the bottom divided by the top. Do the top divided by the bottom. Punch in your calculator, 0.2 divided by 2. Oh, so then you made a mistake. I'm sorry, you made a mistake along the way. You didn't write the correct thing. Trust me, it all comes out to the same. So now compare yours with someone in your group. Compare your work to someone in the group.
Like,
Okay, so I got to move on. I'm way behind schedule. So you do not have to copy the question, but everyone needs to look up here. Oh, I'm sorry, you have to read the question to yourself. So, from the beginning of the year, I've been telling you to look for something first. I've been telling you to look for the total. But that was when we were working with equations that only had one variable. Then in chapter 4, actually at the end of chapter 3, and then into 4 and 5, we've been working with equations with two variables, x's and y's. And so the situations have changed a little bit. And now what we have started doing is looking for things that are different. We're now looking for slope and points. That's usually what we're looking for now, is slope and points. And in this question, we're being asked to write an equation in point-slope form, which means that we know we need the slope and we need a point. And then we can write the equation in point-slope form. Y minus some number, and we fill in the rest. So our job, and this is the most important job that you have, is to learn how to extract the information we need from a description of a scenario. In other words, we would like to translate all of this so that it looks like this. We want it to look like that. Or maybe the slope's in there as well. Who knows? So we have to read through and try and pick out information. So maybe there's a point in here. Maybe there's 2 points in here. Maybe there's a slope in here. So what can you pull out just by reading? Sharik and then Jada?
I see 1 point.
Go ahead, what is it?
It's 2 days and $10. So 2 to 10.
2 days costs $10. So 2 comma 10 is a point that's given to us because x is time and then the y is the cost based on that time. Jada?
4 days.
4 comma 1650. 4 days time costs $16.50. Very good. What else do you see, Ania? Where? Be specific. Be specific. What tells you that that's the slope? Per day. It's a rate, so that's the slope. So we already have this. So all the information we need is already given to us. Sebastian and Catalina.
How could that be a slope at the end? This is supposed to flat surface.
What do you mean? How could it be the slope?
Because if you add a number to it, how could that be a slope?
It's a good question. But what you're missing is 325 per day. So what happens? This gets multiplied by something. Think about slope-intercept form. The slope always gets multiplied by something. Then what gets added on? The flat surface fee is what you pay once. That's why the word flat is there. You pay it once. Okay? But in this question, we don't know what the flat surface fee is. Okay? So we are able to extract the information we need, and now we can write the equation. You were next.
Yeah, I'm not sure if we're gonna get to it, but you know how before when we were doing the slope intercept form, the flat fee was the plus 8. Well, in the point slope form, is there a fee? So you said
There
there
isn't.
wasn't?
And that's the major difference between the two, is that there is no, it's here, it's just hidden. In this form, in slope-intercept form, it jumps out at you. In this form, you have to do some work to find it.
So to answer this one, don't we need the flat fee? And if we're solving it, so
It depends. All we're being asked to do is write a linear equation that relates the information. It doesn't say to then find the flat fee. If you were asked to find the flat fee, then we would rewrite the equation in slope-intercept form, and then the flat fee is exactly what you just said, is the b right here. And you just demonstrated again your ability to connect what we're doing today to what we've done in the past, and that's extremely important. Okay? So, we could finish this. Unfortunately, in the interest of time, I'm going to move on. Okay? But now we have 2 points to choose from and the slope. We can write the point-slope form of the equation. So, I have to modify today. We don't have time for classwork, so here's what I'm going to offer. Everyone will get a free point, but the workbook is available on my website. And so if you do the classwork by going home, doing the workbook, getting the workbook online and doing these questions, you will get an extra credit point in addition to what you would normally get. So when we score the lesson, everyone will get a free point, but then if you also do the classwork, then you will get an extra point on top of it. Okay? And so to make sure that the answers are included in my screencast, I'm going to reveal the answers so that you can check your classwork answers after you do them. Okay? So this would be extra credit. It's good practice, it's important, and it's a way for you to do questions and have the answers right there for you so that you know if you're doing it right. Okay? Now draw one final line across your paper. Your homework is page 311, numbers 10 through 34 even, and 38, 42, and 46. That's a total of 16 questions. And you're going to read the next section, and you're going to have a quiz on 5.1 to 5.4 on Wednesday.